talking about earthquakes. And what is the difference between the focus and the epicenter? What's the difference?
The focus is the underground point where the fault rupture begins.
Very good. Where like the earthquake begins, and what's the epicenter?
Epicenter is the point on the Earth's surface directly above the focus.
Good. So if you go like straight up, it's at the surface. What is a seismograph, and how does that relate to the Richter scale?
It's an instrument that records ground vibrations during an earthquake. The Richter scale is a numerical term that measures magnitude, energy of the earthquake based on the amplitude of the waves recorded by the seismograph.
Yeah. So basically, the seismograph is like a little machine that has a needle that scratches when the earth vibrates. So if you walk next to it, it's gonna go psh, and then if you take another step, it's gonna go really fast.
What if you jump really hard?
Then it's gonna go really fast.
So that means it's gonna be an earthquake?
Well, I mean, it'll kind of detect the movement like an earthquake. Obviously, it wouldn't be accurate because it's not an earthquake, but that's what the seismograph does. And then the Richter scale measures the intensity, like putting it in a number that we can determine, and that's more of the energy. All right, so a lot of the plate movement is actually taking place under the ocean. And that's because the actual spreading and the growth is happening under the ocean. So we talked about convergent and divergent and transform, where the plates are kind of interacting. And most of the divergent or the coming apart of the plates is underneath the ocean. So scientists figured this out by exploring the seafloor. And sonar is one way that they did this. We kind of figured out sonar by learning from animals. Sonar is sound navigation and ranging, and basically you're bouncing sound waves off a surface and then listening to the signal as it comes back. And this is something that bats do as well, and dolphins do it, and other animals that live in the ocean do this also. So if you throw a sound out there and then it comes right back, then that means the object isn't too far away because it just bounces off and it comes right back really fast. Something is close. But if you throw the sound out and then it takes a really long time for it to come back, then that means something is really far away. So you can actually determine the shape, the topography of the ocean floor based on how the sound bounces back to you. And you're doing this by when the sound, is it fast, is it slow, and that variation. So scientific expeditions of the ocean floor began in the 1800s, and in the 1900s, that's when sonar was kind of first developed, and it made more advances in ocean floor exploration.
Students and teachers, pardon the interruption. If you have not counted lunch choice, please do so the cafeteria knows how much food to make. Thank you.
I'm taking out lunch choice. I was good. Look, it's finally vacuums my carpet. The scientists began the map of the ocean floor. They found a lot of interesting things. One of them was the trenches, and these trenches are like these curved valleys, which we already discussed. It's where the ocean floor is dipping down underneath a continental plate. Usually it is happening off the coast because it's not like you have a continent and boom, right there is the edge of the plate. The continental plate extends out into the ocean a bit, so you have a little bit of ocean that's covering the continental plate too. So these trenches are in, like, you know, a mile or so, a couple miles off of the edge of the continent. But it's dipping down and curving down, and it's where the two plates are interacting and making these deep areas. Some of the deepest parts of Earth. We have gotten to the bottom of the Mariana Trench, but there's still not a lot we know about it. I'm just gonna like deposit myself in this tiny little tube and then be dropped to the very bottom, deepest part of the ocean.
That's scary.
Yeah. I mean, how alone, isolated, nothing living that you know of down there. Mid-ocean ridge is a long chain of mountains extending the length of the Atlantic Ocean. And this is where the new plate is being formed. And so you have, we already mentioned that you've got the magma, you've got the convection currents, and the upheaval of the molten rock from the mantle underneath. And so this is the new crust that's being formed. As it rises, because remember it's superheated by the inner and the outer core, and hot stuff goes up. I told you to think of a hot air balloon. So hot air balloons go up, so as the heat rises, but then it's coming into contact with the cold ocean. So it's going to cool really quickly. And as it cools, it's gonna push the crust to either side, and that causes it to make like a kind of a conveyor belt. And the crust is getting pushed to either side, and it makes these like thermal vents here in the center. There's a lot of things that are going to survive here at these thermal vents. Photosynthesis, which you should have heard about because you all had biology, is the use of sunlight to make energy. Well, here at these thermal vents, you have something called chemosynthesis. Chemosynthesis is where bacteria actually make energy by using the chemicals that are kind of spewed out of these thermal vents. So you have like this whole ecosystem that is formed around this area based on these bacteria. quite amazing that, because obviously no sunlight is going to reach this area. So you can't have sunlight to make the food chain, like we normally do. Instead, you've got these, bacterias that utilize chemicals. So chemicals start the food chain, the bacterias use that to make energy, and you can have your, whole nother food web going on instead. Oops. So here are where the ocean ridges are. So this is where plate growth is taking place all along these edges. This is where plates are growing. The most major one obviously is here in the middle of the ocean, and we have these others, but some are really close to the continents, like here and here. Most of them are out in the middle. So the ocean floors are made of igneous rock of basaltic composition. Most of the ocean floor is covered with a thick layer of sediment, except for the top of the mid-ocean ridges, which have this igneous rock from being like basically lava and molten magma. And the basalt forms when the lava reaches the surface and hardens. So the rest of it is like this oozy, dead decomposition stuff from all of the dead and dying material that filters down through the ocean. You will actually have an ocean unit. Usually after Christmas is when we get to the ocean unit. But the part that is along the ocean ridges and where the crust is being formed is different because of the magma that's coming up.
Ghost shark is attracted to the light of the beta remote video system deployed by Tupapa scientists. At almost 2,000 meters, food is scarce, so the bait is very attractive. The video unit lights up this dark world. The rat tails swim slowly to conserve energy. The green arrows indicate the long filaments that help it to sense food and other animals in the dark. This rat tail was observed below 1,000 meters. More than 70 species of rat tails have been recorded in New Zealand waters. Parasitic eels scramble to get the bait, stirring up the sedentary ooze with their fins. The smooth skate is a New Zealand native. Seal sharks are notorious predators and will bite on anything they think could be their next meal. While the hagfish is busy eating the bait, the shark is planning a more animated dinner. When attacked, the hagfish releases a cloud of slime that clogs the shark's gills and chokes it. Hagfish have been around for more than 300 million years, ample time to perfect this effective defense mechanism.
Notice the sediment, it's like so fine particles. Whenever they stir
The
it up,
redfish,
it looks like
base,
powder almost.
hovers among the coral. Fragile coral habitats provide food and shelter for many marine animals.
hydrothermal vent. These are tube worms that live at the hydrothermal vents. We won't watch the whole thing because this is a longer video. We'll only watch a little bit. So you can see like the steam from the hydrothermal vents back there. The tube worms are very common around these vents. They have these kind of funny little red parts to them. Weird looking. And then all these little small parts, like the little barnacles and stuff. So it's like a whole little ecosystem around the hydrothermal vents. But that's a really long video, so we're not gonna watch the whole thing. Alright, so the hydrothermal vents are underwater volcanoes. This is kind of what they look like. There's no sunlight, so they don't do photosynthesis, and they do that chemosynthesis instead, using the chemicals from the vents to create the energy. This is the only place in the world that this happens. Most of the world survives on photosynthesis instead, but chemosynthesis, again, it's the use of bacteria to start a food chain instead of photosynthesis and light to start a food chain. And then with seafloor spreading, new ocean floor forms along the Earth's mid-range ridges, slowly moving outward across the ocean basins, and then sinks back into the mantle beneath the deep ocean trenches. So we already kind of mentioned that it goes up, and the continental crust is just so much thicker that the less dense ocean crust is going down. And again, it's not like the continental crust stopped right at the coast. This usually happens out in the ocean a little bit. Sometimes it'll happen in, like, right up against the crust, but a lot of times we're out into the ocean a little bit when this is happening. Are you guys tired? You seem tired. A little longer. This is kind of a summary. This is in Google Classroom. New ocean floor is formed at the volcanic activity. It pushes the plates apart, and the plates go down, and it heats up. And as it heats up, like when it's going underneath, it creates the volcanic activity. So ocean is youngest along the mid-ocean ridges and oldest the farther away from the ridge. None of the rocks are older than 180 million years. I mean, that's pretty old to me, because all the rock has been cycled through. So as it dips down, it burns and it gets recycled. So it kind of goes in that pattern. But by the time it gets to the continental crust and starts to sink down, none of it is older than 180 million years. It still seems pretty old to me. Alright, well, we're done for today, so that's all the notes. You can continue to work on the gizmo and make sure that your lab is done, because that is due tomorrow, but the gizmo will be due next week. Any questions?
No, I'm probably just gonna take a nap.
Did you finish your gizmo?
I'm almost done with it.
What about your lab? Did you do the reading part at the end? Because there was a reading part.
I finished all of it.
Okay, as long as the reading part's done,